I'm back. I hope you liked my first video. Big shout out off the bat to my 6 subscribers and all the views I've been getting. That's maybe because you have to watch the video, but I'll just think you're enjoying them. So my next video here is on determining empirical formula from percent composition. So you're probably wondering what empirical formula is. So the empirical formula shows the smallest whole number ratio of atoms in a compound. So for example, if we looked at something like magnesium chloride, MgCl2, we can write the ratio of magnesium to chloride ions as 1 magnesium to 2 chlorides. Okay, so let's take a look at an example. So a compound that contains 17.6% hydrogen and 82.4% nitrogen. It's asking us to calculate the empirical formula. So remember, the empirical formula is the lowest whole number ratio. So the EF. So we're looking for NX, so the lowest number of hydrogen or nitrogen atoms to that of hydrogen. So our first step in doing this is to assume that we're working with a 100-gram sample. So if we have 17.6% hydrogen in a 100-gram sample, that means we're going to have 17.6 grams. And the same thing for nitrogen, we would have 82.4 grams. Hydrogen and nitrogen. So our next step is to calculate the moles of each. So let's go ahead and do that. So straightforward, what we've been doing in class, 17.6 grams of hydrogen. We want to use the molar mass of 1 mole of hydrogen. There are 1 gram of hydrogen, so our grams cancel out. So it gives us 17.6 moles of H. Same thing for nitrogen. Use the molar mass, so in 1 mole of nitrogen, there's 14.0 grams of nitrogen. The grams cancel out, and we're left with 5.89 moles of nitrogen. So notice that we're keeping an extra significant figure in that first calculation, and that's because we don't want to run into rounding errors later on. So make sure we keep at least 3 sig figs in these intermediate calculations. Okay, so any intermediate calculations, we want to keep a couple extra sig figs. Okay, so number 3, write the initial formula with the moles of each element. So the way this will look is we use the moles as the subscripts for the elements. So nitrogen, there's 5.89, so as a subscript, and hydrogen, it's 17.6 because that's the number of moles we calculated in the last question. In our next step, we want to take that initial formula and divide by the smallest number of moles to get a whole number ratio. So we have N 5.89, so rewrite our formula here. We're going to divide that by our lowest number, which is 5.89, and we end up getting N1 and H 2.988. Okay? So 2.988 is close enough to 3 that we can round to the nearest whole number, and that's NH3. Okay, that's our final answer for that question. So just as a side note here, or just a note, if you can't round initially, you want to keep 3 or more decimals in the subscripts. That's if you can. Again, we want to avoid rounding errors. Okay? So because we're not going to get always these really close numbers to the whole number, we need to have some rounding rules. All right, just going to shift it over here. So if we have numbers that are 1.9, we can round 1.9 up to 2, okay? Or if we have something like 1.1, it's close enough to the whole number to round down to 1, okay? However, so I'll just put a check mark because those are okay. However, it is not okay if I have a number like 1.3 to round down to 1. That is too far away from that whole number to round. Okay, so what you would need to do is we would need to multiply both the numbers in the compound by the lowest number that will make both whole numbers. So let's go through an example. So if after you divide the smallest number of moles to get the whole number ratio, and you end up with something like this, 1.49 and 1.49 and H2, 1.49 is too far away to be able to round up or down, so I'm going to need to multiply this by the lowest number possible. So it's close enough to 1.5 that if I multiply by 2, I can get 3. So I'm going to multiply both by 2, so both the subscripts by 2. So in doing that, I get the answer of N3H4. Okay, so let's just make the note of that. So if you do get a question that ends up like that, you want to multiply both by the lowest number that will make both whole numbers. Okay, usually on tests and quizzes it'll be very obvious, okay, but sometimes on a worksheet you might encounter a number that you might have to multiply by something other than 2. Okay. All right, so hopefully you feel comfortable with that. So go ahead and try the practice problem there that you see on the bottom of the page. So pause the video here, try the practice problem, and come back for the answer. All right, welcome back. So hopefully that question went well for you. So the question asked, Ultra Sweet is 57.4% carbon, 6.16% hydrogen, 9.52% nitrogen, and and 27.18% oxygen. Sorry, I thought something got deleted there. Determine the empirical formula. So the first thing you want to do is assume a 100-gram sample to calculate to find the masses of each element in the compound. Then you want to calculate the moles of each. And then from there, you want to divide the initial formula by the lowest number of moles. And then you want to, because you end up getting C7, H 9.06, N1, and O 2.5. 9.06 is close enough to 9 to round down. 2.5 we would have to multiply by the lowest number to get whole numbers. So I multiply everything by 2, so this 2 applies to all these subscripts. And I end up getting my final answer of C14, H18, N2, and O5. So please feel free to go back, review, rewatch, and enjoy. Have a good day.